Installing bearings in hubs, free hubs, and suspension can be as easy as turning a tool. Just give it a twist and the bearing goes in. Looks easy, and that part is, but a fair bit of planning went into figuring out what tool to use and how to set it up. And in order to be able to do that, you need to understand some fundamentals about bearings and how they go into components. Plus, if you want your bike to function exactly as the manufacturer designed it, you may have to follow some additional procedures and recommendations by your manufacturer. Once you follow all that, turning the tool is the easy part. So this is actually the second video in a series. In the first video, I removed all the bearings found in hubs, free hubs, and suspension. In this video, I'm going to be doing installs. But in that first video, I discussed a lot of technical ideas that you really need to understand before you watch this video. So if you're interested in bearing swaps, go watch the other video first, then you can learn the installs. And another thing, that there are 3 main bearing arrangements, and although I might be demonstrating on, say, suspension in a single pivot bearing arrangement, you might also find that bearing arrangement in hubs as well. So don't get hung up on the type of component I'm demonstrating on. You could find it anywhere. So what are some of the things that we're going to need to know before we actually start installing bearings? Well, for starters, let's talk about cartridge bearings. It's actually an assembly of parts. There's an inner bearing ring, some balls, and an outer bearing ring. The balls ride in grooves in the bearing rings, and they transfer radial and axial forces from one bearing ring to the other. Simple as that. But there's a lot of different specifications to the designs of a bearing. There's bearings with extended inner rings. There are flanges on the outer rings. Often there's some kind of seals to manage grease. Bearings come in different standard sizes for their inner diameter, outer diameter, and their width. And bearings come in different designs, like deep groove, which are symmetrical, angular contact, which are not symmetrical, single row or double row bearings. Another thing that you're going to want to be aware of is not all bearings are symmetric. They need to be installed in a certain orientation, either this way or this way. So let's take a look at the different ways that bearings can be non-symmetric. All right, here's some bearings that I pulled out of my personal collection. Let's start with some bearings that have obvious non-symmetrical features to them. This has got a flange on it, so this clearly gets installed in a certain direction. If it's not obvious, the schematic diagram for the bike part is going to help you know which orientation to put that in. Here's a bearing with an extended inner ring. These are known to go into components in either direction. You definitely have to look at the schematic diagram to find out which direction that goes. This bearing has a steel seal on one side and no seal on the other side. This is so that you could grease while this is installed in a component. You can pump grease through here and the old grease comes out this way. This definitely goes in a certain direction. And once again, check your schematic diagram. Here's a bearing that doesn't have any flanges or extended inner rings. Oh, but the other side has a red seal. Red seal, black seal. So this is an angular contact bearing of some sort. You may have heard the old adage, when you have an angular contact, that the red seal points outwards. Well, that may be the case in certain situations, but you're definitely going to want to check. This is an angular contact, blue seal, gray seal, green seal, black seal both sides. No flanges, no extended rings. This is a symmetrical bearing. Let's not talk about that. Okay, so maybe the rule is colored seal outwards, but I certainly wouldn't chance it. Contact your manufacturer and find out which direction your bearing should be installed in. So when doing bearing swaps, a manufacturer will almost always recommend using a bearing press to install the bearings. And you'll remember from the removal video that there are 4 functions to remember when pressing a bearing either in or out. There's pressing, leveraging, centering the tool, and then planning for when things move, plan for some clearance. Now, in order to do these 4 functions as versatile as possible, I've created the Alt-Alt hub and suspension bearing press system. It's made up of simple, multifunctional pieces that you use to build the tool that you want. What do I mean by multifunctional? Well, take the Drift RE for example. It's primarily used for pressing. So when you're pressing a bearing, the relief side of the Drift RE will press only the bearing outer ring, whereas the flat side of the Drift RE is capable of pressing both bearing rings at the same time. But the Drift RE can also be used for leveraging. So in the case of a rocker link, sometimes this area is very small and you can't fit large leveraging pieces. So use a small Drift RE in here to press in the bearing. Use it as the leveraging piece. Now, what if that bearing had an extended inner ring in it? Well, the Drift RE, the relief side, can provide clearance for this extended inner ring so that you're only contacting the bearing outer ring. So it provides clearance as well. Now, what if that bearing actually got installed this way into a link like this? Well, in that case, when it reached its final position, that extended inner ring could actually stick past the frame. So in that case, the Drift RE relief side provides enough clearance for that extended inner ring. And finally, in the case of a BSB hub, when you're installing a bearing in one side, often a manufacturer will recommend that you use a drift inside the empty seat. So in that case, use a second Drift RE to leverage and center inside. That makes installing this bearing nice and square, keeps the tool very straight. So the Drift RE can be used for all 4 functions, and the other pieces of the Alt-Alt system operate similarly. So when choosing pieces, think that you could use any of the pieces to build the tool that you need. It's actually the key to why the Alt-Alt hub and suspension bearing press system is so very versatile. All right, let's get to installing some bearings. Now, you remember from the removal video that there are only 3 kinds of bearing arrangements in hubs, free hubs, and suspension. And those bearing arrangements are a simple pivot, a BSB bearing arrangement, that's bearing spacer bearing, and then the last one is the overaxle design. Now, when installing a bearing into a simple pivot bearing arrangement, you're installing one bearing into a component. But the BSB and the overaxle design are multi-bearing bearing arrangements. However, manufacturers often recommend that when installing bearings into these bearing arrangements, you install them one at a time. So basically, when you install the first bearing into these guys, it's done like a simple pivot. You're installing one bearing into a component. So let's take a closer look at the simple pivot and figure out what to press, what to leverage, what to center on, and how to apply clearance. So here we have our simple pivot bearing arrangement. One component, one bearing. Nothing else getting in the way. So this bearing has to go into the component, and it goes in to what's called a seat. Now this seat is slightly smaller in diameter than the bearing is. So the bearing needs to be forced into the seat. Now, if you think about it, the interference fit is between the seat and the bearing outer ring. So because the bearing is made up of different pieces, you need to press on the bearing outer ring to overcome the interference fit. So the tool piece that you choose has to contact the full bearing outer ring. You're going to be pressing on the bearing outer ring until you hit what's called a shoulder. Now, this is a Drift RE. You could use the flat side or the recessed side to press on that bearing outer ring. But just know that if you're going to use the flat side to press, that you put something between the handle and the drift. In some of the sizes, this is awkward and not great. So choose something like this, the spacer tube, to press nicely up against there. So we're going to just use the bearing outer ring to do that. So we've chosen the drift RE. Now note, if you don't fully contact the bearing outer ring, then you're essentially pressing on the bearing inner ring. And what that's going to do is going to press the inner ring, it's going to contact the balls. The balls are then going to press against the bearing outer ring, and then that's what's going to press the outer ring into the component. It will go in, but what's going to happen is that the balls are going to dent the inner ring and they're going to dent the outer ring. And over time, that's going to wear out the bearing a lot faster. So this is why people use well-designed tools and not just washers and stuff you find around. So we're going to install this bearing into this simple pivot. Now, to counteract the force that we're going to be applying, we're going to want to leverage up against the back side of the component. Not all the way over here, because we might bend the component, and bending the component may change the angle of the tool. And when installing a bearing, you want to make sure that the bearing goes in straight. If it goes in crooked, not only is it going to be very difficult to press in, but you're going to damage the seat. And once you damage the seat, you may have to replace the component. So you don't want to do that. You want to keep things nice and flat. So the leverage surface back here needs to be perpendicular to the axis of the bearing. So we're going to use a drift RE. It's nice and small. Sometimes this area can be cramped, and it fits securely on the back side there. Now, it may also be worth noting that I make tool pieces in acetal and aluminum, and sometimes you can use both. Like here we got an aluminum component, so you can use a nice strong aluminum drift behind there. And that's also good because sometimes this leverage surface is very small, so you have to use a nice strong tool. If this were carbon or precious paint and highly visible, you might want to use an acetal piece. Now this is slightly softer than aluminum. So just keep in mind that you might want to use aluminum or acetal as a leverage piece. The next thing to consider is centering the tool on the bearing. So we have a threaded rod and we need to center it. So what we're going to do is we're going to use the largest size pilot to fit inside the bearing. This way, when we put the drift behind the bearing, the drift lines up with the bearing outer ring. And this pilot that's in there also keeps the bearing from rocking as we install it. Now we've got our centering piece, which is the pilot. And then the final thing that we need to consider when we're choosing the pieces to press a bearing is we need to compensate for clearance. This is going to move as we tighten the tool. So let's finish putting the tool together. We're going to install an O-ring on this end to keep this all in place. I'm going to put a handle on, although you can use the nuts, but the handle is nice and fast. So here we got our pressing, we got our centering, we got our leverage piece that we're going to use. And when we put it all together, we got to think about what's going to happen when we tighten this handle. It's going to press the bearing in. Now the bearing's going to move. There's nothing sticking out of this side. We have a little bit of clearance on the drift here because we're using the recess side of the drift. So if there is anything over here that gets stuck out past this surface, we're going to have clearance. So clearance has now been considered. Now it's just a matter of tightening the handle and pressing the bearing in. Had I put a threaded fastener over here. Here we're using the stud stop. And the stud stop, as you can see, allows the threaded rod to slide through when it's crooked. When you straighten it up, it engages the threads. So let's get the bearing ready to go into the seat. It's looking good. Stud stop's nice and straight. Tool is nice and straight. So now we just tighten and the bearing goes in. Bearing's in, and you can see there's no extra gaps here between the bearing and the shoulder. So the bearing's in position. That's the simple pivot. Now the next bearing arrangement we're going to tackle is the BSB bearing arrangement. Now that's bearing, spacer, bearing. Now there's a few different variations of this. Sometimes the spacer moves, sometimes it doesn't move, sometimes there's no spacer. And these different variations mean that you need to press on different things, leverage on different things, and maybe center on different things. So let's start by taking a look at the simple BSB bearing arrangement. And I know that this Santa Cruz Blur has two of the simple ones. One down here in the seat tube, and then one here in the linkage. So let's take a look at that. Alrighty, we're going to be looking at this BSB. We're going to be using the rocker link here. I've taken out the bearings with the help of the alt extractor. That was great because it didn't damage the bearing spacer at all. And then I went and I cleaned out the seats with degreaser and isopropyl alcohol. So this is all ready to get installed. Now looking at the actual BSB that we have, we got bearing, spacer, bearing, and the bearings go in one from each side. The bearings are also symmetrical bearings, which is great because we don't have to worry about which orientation we put them into the bike. Now, I'm going to be just reinstalling the old bearings. You're not. You're going to be installing new bearings. That's the purpose of the whole thing. So normally when you install bearings into a BSB, you install one bearing in first, and then later you install a second bearing. But that's not always the case. Some manufacturers recommend that you install both bearings at the same time. Santa Cruz recommends installing one bearing at a time. So when we're going to install this one bearing, we're going to install it like the simple pivot that we already talked about. But let's go into a little bit more detail. So looking at Santa Cruz's website, I looked at the tools that they use for installing bearings. Now, the tool that they chose to do the pressing actually has a flat surface on it. So you're pressing both bearing rings. Now, when installing a simple pivot, the inner bearing ring never actually contacts anything. All the force goes through to the outer bearing ring. So since nothing ever contacts the bearing inner ring, the inner ring is just going along for the ride. It doesn't matter that you have a tool piece behind it here. So we're going to use the recess size for the Drift RE because the back side is actually flat and it works great against a handle or a nut. So in this case, we're going to be using the Drift RE to press on the bearing outer ring. Now to center the tool, we're going to use a pilot. So we'll choose the largest pilot. That's great. When it all goes together, it's going to sit like this. And I just like to make a little comment about what pilot to use because you got short ones and long ones to choose from. Now in this situation, you got not a very wide bearing, and the pilot sticks out here, which is great. It supports the bearing fully and keeps it from rocking. But what if you had a big honkin' wide bearing like this? Well, sometimes the short pilot isn't long enough to fully extend past. And although that's fine, sometimes you want a little extra insurance, so you could use a long pilot. Now, the only consideration is that when using a long pilot, you have to make sure that you have the clearance. And since we're going into a BSB and we're not going to get near anything, we can use a long version. So in this particular case, instead of using the short pilot, we're going to use the long pilot just for demonstration purposes. So that's our pressing piece and our centering piece. Now on the other end, for the leveraging piece, I took a look at Santa Cruz's instructions. They have instructions. Some have been written out for some bikes in their past, and they have a video up on their website. And for the leveraging piece, what they actually used in the video was they leveraged up against this surface. So when leveraging up against this surface, you have numerous tools that you could use to do that. But if you were going to leverage up against this surface, I would choose the Stop CTR. it's got a conical shape to it. So not only does it provide leveraging, but it also provides centering. After looking at more of Santa Cruz's instructions and the tools that they use, they've also leveraged sometimes inside here with a second drift. And it's inside the seat and up against that shoulder. Now, in order to do that, you need a second drift RE of the same size because your bearings are the same size. So that's what we're going to do in this example. We're going to use the recessed side because that side's flat. This surface here will rest up against that nice sturdy looking shoulder that they got in there. So that's going to be our leveraging piece. And the last thing to consider before installing the bearings is whether to use grease or not. Now, their instructions say to use grease. It says re-grease all mating surfaces. And I did find some videos that show re-greasing. On the video on their main page, they didn't, but must mean that you can grease or not grease. It must not be that big of a deal. So in this case, when we install, we're going to use the new Alt grease kit. So let's get to installing. So first thing we're going to do is we're going to grab the stud. We're going to put an O-ring on here to keep a pilot in place. That's our centering piece, our pressing piece. We're going to use the handle just because it's quick and easy. We're going to grease this seat. Just a little grease. Grease the outside of the bearing. Bearing goes on here. It's symmetric, so we don't have to worry about which orientation. We're going to press it into this side, and then we're going to use our opposite drift RE as a leveraging and centering piece on the other side. That keeps the tool really nice and straight. And straight is the key to installing bearings. Tool's all stable, feels really good. You simply twist that in. This was essentially the process of a simple pivot as the first bearing in a BSB. There it is. All right, so installing the second bearing into a BSB. This is normally where the BSBs vary from each other, and it all comes down to what you're pressing, what you're centering on, what you're leveraging against. So in this case, let's have a look. So the first thing we have to do is press on the bearing. Now, Santa Cruz uses the same tool pieces for their install of the second bearing that they did for the first bearing. So that was a flat piece. So they're pressing up against both bearing rings. Now this is different from pressing the simple pivot because in this case we're going to be also installing the bearing spacer, and the bearing spacer sits between the two bearing rings against the inner ring. So at some point that inner ring is going to be contacting something. So we're definitely going to use the same shape tool that Santa Cruz does. So that's our pressing piece. Now we're going to need a centering piece. So we're going to use a pilot again. This time we're going to use the long pilot because when we install the bearing spacer, it's nice to center it on the bearing as well. So we're centering the tool, we're centering the drift on the bearing outer ring, we're centering the bearing spacer. This is going to keep things nice and straight. So that's what we're going to be doing there. We got pressing, we got centering. Now on the leverage side of the piece, Santa Cruz leverages against the bearing using another drift. So we're going to use a second drift RE, same size as the first because the bearings are the same side, and it presses up against both bearing rings. So we're going to use that, and then we're also going to center the tool on the leveraging side as well. So now it should just be a matter of greasing this stuff up and assembling the tool. But because we're using the flat side to press, we need to press up against the recessed side, and I don't want to just press the handle up against there. So I'm just going to take the opportunity to show what you would do if you were in one of these awkward sizes where the handle doesn't rest up against there very nice. So what we're going to do in the first pressing piece, we're going to put a spacer tube up against there. And then on this side, we're going to use something else. We'll use, I don't know, just a big drift. There we go. That'll work really well. So now let's assemble the tool and get this bearing in. Start with a little bit of grease. Grease up this bearing. There we go. Okay, this is symmetric, so it doesn't matter what orientation. So that's ready to go. I'm going to put the spacer on there. There, let's center that other side. There we go. And then use the flat side. And okay, tool's all nice and straight, stable. So let's press that second bearing in. Once it gives you a little bit of resistance, that means it's time to stop. There we go. Second bearing's in. Nice and smooth, turning great. I'm going to just stick this in there and feel the spacer. All right, spacer isn't flopping around in there. That means I push the bearing to where it's supposed to be. So here we go. First BSB done. So here we are on the Alt website, and we're at the bearing arrangements here, and I just want to look at this BSB bearing arrangement. Now this bearing arrangement is almost exactly like the bearing arrangement we just looked at. The only difference is that the bearing spacer here is a lot shorter. So after you install the first bearing, installing it like a simple pivot, when you go to install the second bearing, you're not going to be able to use the long pilot on this side to keep this spacer aligned with the bearing. So you're going to have to use a short pilot over here, and you're going to have to just make sure that this bearing spacer is just positioned between the two bearings, and you won't be able to center on the leverage side. So just keep that in mind and proceed with a little bit of caution. Once you do it once, it'll be easy the second time. Okay, this is going to be an interesting one. This is the new Project 321 Gen 3 rear hub, and this one's interesting because it's a BSB, but there's no bearing spacer in the middle of it. So when you're installing the bearings, you actually install them like simple pivots. You have to press on the bearing outer ring to get past the interference fit, and then you just got to make sure you leverage and center on the hub properly. So let's go through this because I found this one quite interesting. Let's start by installing this non-drive side or disc side bearing. Now it's kind of neat. The bearings are different sizes, the bearing are different widths. I love the way these guys are optimizing the bearing loads. That's so cool. All right, so we're going to install this disc side bearing first. So we're going to pick a drift RE. We're going to press on only the bearing outer ring, and then we're going to center using a pilot. That's looking good. And then on the leverage side, I'm going to leverage against this inside surface here. It's nice and stable. I don't want to leverage on this little shoulder that's in here. I got to check with these guys, see if they recommend that, but you know what? We don't have to, so I'm not going to. So what we're going to do instead is we're going to leverage against this surface here, and let's pick a piece. We're going to use a sleeve, and we're going to use a sleeve because I want to use a drift RE inside the bearing seat so that the tool stays straight on the leverage side. We're pressing in this side. This is going to be the leverage side. So this is going to keep the tool straight. This is going to be our leverage piece. Let me just grab a step and other side. There we go. Leverage piece, centering piece on the leverage side, pressing piece and centering piece. That's awesome. So I know that Project 321 does not use grease inside of their seats, and the bearing is symmetric, so we don't have to worry about that. So let's install that first bearing. Let's assemble the tool. All right, bearing is ready to go in. Now let's assemble the leveraging side. This is just going to center, so it doesn't actually matter which way you put it around. Nothing's going to be pressing up against it. We've got clearance for this. Speaking of clearance, we are not going to run into anything, so that's not going to be a problem. Maybe we want to hold this in place. So let's get this together. There, let's just put an O-ring on here so that this centering piece isn't going to move around. There we go. Let's take our leveraging setup here. That's nice. Okay, nice and square, stable. Let's just press that first bearing in. There we go. Okay, the first bearing's in. Awesome. Now let's press that second bearing in. Okay, choosing the pieces to press, leverage, center, and clearance the second bearing. So second bearing, let's grab a drift RE. Now we're pressing the bearing outer ring. The bearing inner ring isn't going to contact anything, so we don't have to press on it. We're going to need a centering piece. So let's use the long one. There we go. So we're pressing and centering there. And we're going to leverage on the opposite side. And here we got a center lock disc brake mount. So we're going to leverage and center with the sleeve long. Grab the step. We're ready to assemble already. Okay, put the pressing piece and the centering piece on. Let's put an O-ring here to keep that in place. Bearing is also symmetric, so we don't have to worry about that. We're not using any grease. And then this is not centered right now, but as soon as we stick this on, we're centering and leveraging. Excellent. Put it together, and that's it. It's essentially like doing another simple pivot. No bearing spacer to worry about. And there we have it. Project 321 rear hub, both bearings installed. So here we got yet another BSB bearing arrangement. This is a microspline freehub or driver, and it's got two bearings in it and a spacer. And the unique part about this is both bearings in the spacer come out the outboard side. You don't have access to remove anything from the inboard side. You can see the bearing, but you can basically only see the bearing inner ring. So installing the bearings is going to be a little bit different than the other installations that we looked at. So I took the first bearing out, and there's something in here I want you to take a closer look at. Can you see that retaining ring down there up against the inboard bearing? You're going to have to remove that before you can get that bearing out. Also, take a look at this surface here. This is where the outboard bearing sits. There's no shoulder to stop the bearing when you install it. We're going to want to talk about that in a second. Okay, so I took everything out of it, and you got a bearing, a retaining ring, a bearing spacer, and the outboard bearing. I don't know whose free hub this is. It was just given to me. I do know that the outside design is microspline, but the inside design, that's all up to the hub manufacturer. I don't know who this is, so I can't go find any schematics. So I'm going to have to figure this one out. First thing I notice is that it's all very clean in here, which suggests that this wasn't installed with a bunch of grease. So when I install the bearings again, I won't be using any grease. Next thing I noticed was this bearing is symmetrical, and this bearing is not. This is an angular contact. That's a runaway bearing spacer. So if you were buying bearings for this, you would have to make sure to buy exactly what you pulled out of the free hub. So to install bearings, we're going to install the first bearing, and we're going to install it like a simple pivot. So let's choose some pieces. This is the inboard bearing. It's going in first. We're installing like a simple pivot, which means that we're only going to be pressing on the bearing outer ring. So let's pick a pressing piece, pick that, a centering piece, good. We got pressing and centering going in. We're going to need a leveraging piece on this side. We're not getting anywhere near the bearing, so I don't have to worry about any clearance issues. I'm going to use a stop CTR to leverage and center on the opposite side. So let's go ahead and install this bearing. So because it's a symmetrical bearing, we can put it on in any direction. And now before we install this, this bearing is going to be installed all the way into there. And when I was removing it, I noticed that it was tight the whole way. So this seat for the outboard bearing is actually the same dimension all the way going in. So I'm going to feel a little bit of resistance all the way in. And I'm going to run into a depth issue. So I'm going to install a spacer tube onto there so I can get a little bit more depth. Okay, now I'm ready to press that bearing all the way in here. Center and leverage on the opposite side. Grab a stud stop, nice and quick and easy. All right, this is going to take a little bit of spinning, so. All right, that bearing's installed right to the end. So we're going to install this retaining ring. Then it's time to install the outboard bearing and the spacer. So let's pick some tool pieces. When installing this second bearing, remember that there's no shoulder here for this bearing to stop up against. Well, where is this bearing going to stop? Well, this first bearing is already installed. Then we install the spacer and then we put the bearing in, right? So we need to press on the bearing outer ring to overcome the interference fit with the bearing seat. But we need this bearing to stop when the inner ring contacts the bearing spacer. So the tool piece we're going to want to use is going to be a flat side of a drift, so that we press the outer ring to overcome the interference, and then when the inner ring contacts the spacer, the piece stops it. So that's the drift we're going to want to use, but we're going to want to use the other side of it. Okay, now we're all set up. Let's grab the bearing, red seal out, no grease, pressing the outer ring and the inner ring. Got the bearing spacer. It's ready to go in. Going to use a leveraging piece and a centering piece. I'm going to use the stop CTR to perform both those functions. Tool's nice and square and stable. So let's push that second bearing in. There. I can feel the bearing inner ring hit the bearing spacer. There we go. Feels good. Just going to check to make sure that the bearing spacer isn't flopping around. So that's good. Before we're done talking about this BSB, it's important to mention that when installing the second bearing and the bearing spacer, it's important not to over install it. So when you install the first bearing, the housing holds on to the bearing outer ring. Then when you go and you install the second bearing and you're using a drift with a flat face, you're pressing on the inner ring is pressing on the spacer, and then when you go to install the whole thing, it contacts the other bearing's inner ring. And if you keep pressing, it will force on the inner ring through the balls to the bearing outer ring. If you apply too much pressure, you will dent either the balls or the rings, and that will shorten the bearing life. Important not to do that. Just another note that the retaining ring doesn't come into the picture because the spacer passes through it. So keep that in mind when installing. So this is the last BSB bearing arrangement we're going to look at. Now this is the Project 321 Gen 3 front hub. Now just looking at it, bearing, spacer, bearing, you'd think, well, that's exactly the same as the very first BSB we looked at in this video. Well, what makes it different is something called preload. Did you know if you push the bearing inner ring and hold the outer ring, the inner ring will move? It's so small you can't even feel it, but there is play. This thing's an assembly, the inner ring, balls, outer ring. There's a little bit of movement. And what some manufacturers will do is they will offset the bearing inner ring just a little bit so that the inner ring touches the balls, touches the outer ring, and then that play is gone. This is actually what bearing preload is. Let's take a closer look at this. Here we got our bearing spacer bearing arrangement, and we're going to put a hub around this. I'm going to cut it in half, and we're going to take a closer look at what's happening to these rings. So this is the regular BSB bearing arrangement, and this is the one we looked at in the beginning of the video. And you can see here that the shoulder inside of the component and the bearing spacer are holding the bearing in a very neutral position. This is going to spin very easily. Some manufacturers want to get rid of the slop in the bearing, so what they do is they preload the inner ring a little bit. Now the balls are touching the inner and the outer rings and the slop is gone. Now there's more than one way to do this, as you can see in the opposite direction. And there's definitely more than one way to get to this preloaded bearing state. So all this theory talk about preloaded bearings is really beyond the scope of this video. I just wanted you to see what was actually happening. Preloaded bearings are common in hubs, so look for special instructions when you're doing hubs. Now, a manufacturer isn't necessarily going to tell you how they preload a hub or why they preload a hub. Some manufacturers will preload it like that just so that when you put a through axle through and you clamp it down, it shrinks the bearing spacer a little bit and brings the bearings back into a freer alignment. They don't have to tell you that. What they do have to tell you is what kind of tools to use to install the bearings. So if they tell you to use a flat surface, use a flat surface. Keep in mind, a flat surface is actually standard practice in history, so you might want to consider that. If they tell you to use a recess tool that only presses the bearing outer ring, definitely do that. So let's take a closer look at this Project 321 hub. Let's go through installing the bearings and I'll share some of these details. Now, with any bearing arrangement that has preloaded bearings, you're going to want to find out what the manufacturer recommends, and what you're specifically looking for is what bearing rings to press up against. They might also tell you things like what to leverage against. They might say what order to put the bearings in, and they may or may not say whether to install the bearings with grease or not. So this is the Project 321 Gen 3 front hub, and I contacted Project 321 and I got their recommendations. So we're going to install the bearings on this. We're going to start with one bearing at a time, which is what they recommend. So they recommend starting with the disc side first. They recommend leveraging in the opposite side open seat, and they also recommend installing bearings without any grease. So let's get choosing some tool pieces for that. So first thing is a pressing piece. Since the first bearing goes in like a simple pivot, we could press just the outer ring or both rings. I'm going to press the outer ring just because it works better with the alt-alt system. Then I'm going to grab a pilot to center. And then for the leveraging side, which is the opposite side, I'm going to choose another drift RE to fit inside the open seat. Now this leverages and centers. And that's it. Let's get to that. Oh, and also note that this is a symmetric bearing, so it doesn't matter which way you install it. So disc side first goes in. Put the leveraging and centering piece in, grab a stud stop because it's nice and easy, and that's it. First bearing is going in. Okay, so the first bearing is in. Now to install the drive side bearing, Project 321 recommends installing by pressing on the bearing outer ring. Now we're going to use a tool like that to press on only the outer ring. They also recommend leveraging on the first bearing that was installed, but only the outer ring. So we're going to use the recessed side for that. So the only thing I want to change is the centering. So instead of having a short pilot, I want to use a long pilot. And I want to do that so that I support the bearing spacer when I install this bearing. So we're going to install the drift so that we can press only the bearing outer ring again. Now, when we install the bearing, which is also symmetric, doesn't matter which orientation, we can support the spacer as well. Now this all goes into here. Oh, it looks like we should put something in there maybe to center the tool, keep it more square. So let's put another pilot in there to center the tool. There. Good. Here's our leveraging piece up against the bearing outer ring. And this is all ready to go. Now, the only thing that Project 321 also recommended was that the way they want you to press this in is tighten just until you feel a little resistance. Now, what's happening there at that point is the bearing inner ring is just moving off and the balls are now contacting both bearing outer rings. So be careful when you're tightening this tool to feel for that moment. Yeah, resistance, resistance, a little more resistance. There we go. So now let's take it apart and double check. Okay, both bearings are in now. That's not tight enough. You can hear the bearing spacer flopping around in there. So let's put it back together again. Okay, good. It turns smoothly. I think we have a good bearing install here. So here we are at the final bearing arrangement, the overaxle design. Now, the BSB and the overaxle design are really quite similar. Both of them have a bearing spacer that sits between the bearings and holds the bearing inner rings apart. The only difference really is that on the overaxle design, the spacer protrudes through the bearing ID and it kind of gets in the way. So you can treat them quite similarly, but just use different tool pieces. So let's take a closer look. So in the overaxle design, there are two variations. The first is where the axle protrudes past the bearing, and in the second variation, the axle does not protrude past the bearing. In both variations, when you install that second bearing, you're going to have an axle to deal with. Let's look at the long variation. So as you can see, installing the second bearing, if you tried to use a drift RE, the axle would foul before you got the bearing into place. So you can't use the drift REs, so you have to use an overaxle drift. Now, these fit over the axle and they center, and they press on either the bearing outer ring with the recessed side, or with the flat side, it presses on both bearing rings. So you use that to press the bearing in. On the opposite side, you leverage with another overaxle drift. That also centers, and you're leveraging up against the first bearing installed. And once again, you have an option pressing only the bearing outer ring or both rings. These are as per your manufacturer's instructions. So this is the setup for pressing and leveraging. However, when you're using the overaxle drifts, you have to remember they're open on both ends. So if you just go ahead and use a handle, you might have the support you require because of these large holes. Same with a nut. It's not enough surface. So you have to use another drift, either like this, or pick a good size that fully supports the end, and you have to do that on both sides. So let's go ahead and install the second bearing into this hub. So let's start with the pressing piece. Choose a size that fits over the axle and matches the outer diameter of the bearing. Use whichever side your manufacturer recommends. Also, grab a drift to fit up against the back side of the over axle drift. Choose a size for the opposite end, same way. Pick the inner diameter of the over axle drift to fit over top of the axle, and the outer diameter that matches the bearing you're leveraging up against. Leverage with whatever side the manufacturer recommends. Choose another drift to fit up against the side of the over axle. Now, if we assemble the tool like this, the stud would flop around inside the axle. So we're also going to grab some pilot that fit inside, and we're going to use those to center the stud. So let's assemble the tool. Let's start with getting some of these pilots in place. I'm going to pop a pilot on this end, and I'm going to use O-rings to keep the pilot in position. That will fit in that end. Keep the stud inside the axle. We're going to leverage using only the outer ring. We're going to pop a drift on there and then a handle. And this is going to be the leveraging side. On the pressing side, we're going to put another pilot in there to center the tool inside the axle. Then we're going to place our bearing with grease or without grease as per the manufacturer in the proper orientation that the manufacturer recommends, and pressing the rings that the manufacturer recommends. Got another drift there. Here we go. Make sure everything is square and sitting properly, and then press the second bearing in. Once again, not applying too much pressure. There we go. Both bearings installed. And watch out for this situation. Here you can see the bearing fits on a stepped part of the axle. And if you were to size the over axle drift to the bearing ID and the bearing OD, the over axle drift wouldn't center. And it wouldn't center on the bearing either. So you have to size the over axle drift to the axle OD and the bearing OD. And when you're pressing the second bearing into the short version of the axle doesn't get in the way of the pressing function. So you can use a drift RE to do the pressing in that case. But remember, you're going to need to center the bearing on the tool. So use a pilot. And then, so you want to center the tool inside the axle. So use a pilot there too. And this is the setup that you'd use to press in that bearing. So in the last video, you learned how to remove all the bearings found in hubs, free hubs, and suspension. And in this video, you learned how to install them all. It's just a matter of finding out what your manufacturer requires and then pressing against the right bearing rings, leveraging against the right surfaces, centering the tool so it stays nice and square, and then planning for a little bit of clearance. And you can do it all with the Alt-Alt hub and suspension bearing press system. Whether you're a home mechanic who only has to do a couple of bearing swaps, or you're a small shop who needs every removal and installation functionality possible, having everything together in one system is a huge benefit. So take a look at the Alt-Alt website, sniff around, look at the instructions, look at the instructional diagrams, look at the bearing basics, and then if you got some questions, feel free to contact me through the email. I'd love to hear what you have to say. It's how I learn about the new functionality that everybody needs. So see you in the next video.